So, Super Jerry's parents are watching the stream, or are they watching the football? They're watching the stream. I don't know. Okay, so you may notice that there's a new section that I just added before I started streaming, which is an entity. So, what I want to do today is I'd like to have an end to the game, which is kind of the point that you're supposed to be getting to in the game, right? And I figure it might be quite nice to have that sort of denoted by a coloured square and a particle, like a particle emitter. So what we have right here is what's going to be a particle emitter entity, which is going to generate new entities which are particles around it, if that makes sense. So we've got the position of the particle emitter, we've got the type of entity that it is, so that we know to treat it as a particle emitter. We've got the frequency that the particle will come out as. We've got the particle texture, which is this purple ball thing up here, and we've got the emission width and height. So this will spawn particles randomly within a width of 40 blocks, 40 pixels from this x coordinate, and 0 in the up and down from the y of 300. That should appear somewhere over here. Not entirely sure where. So yeah, that's what we're gonna try doing next. So we've got our entities listed in the level now, which is cool, and we're going to build in some handling for the entities, which is going to go right here. So we're going to go for I equals 0, I is less than level dot entities dot length I plus plus. So this is just going to be a loop which is going to loop through all of the entities we have in our level, which is all of this stuff right here. So we've got one entity currently. So if we just console.log I, let's just log this and just check that we have one entity registered in our system. It's just uploading. As always, you can go to accidentalgames.com/canvas to see this live, or to see the most recent version if you're watching this as a video. And if I press F12, we'll actually be able to see what it's printing. We are getting one entity. Great. So let's have a look. We need to draw the entity, but the particle emitter entity is going to be invisible, so we don't actually have to physically draw anything, although I suppose we could draw a little point there for now. We've got our x and our y and our width and our height. So I guess for now, let's draw a little square there just so we can see where it is. So we're going to, let's have a look. We're going to we're going to go if level dot entities dot length. Oh, you know what? Let's yeah, but we'll go with that. Level dot entities. I kind of want to shorten that to current entity. Current current equals level dot entities I. So if current entity is equal to current entity dot type is equal to particle emitter, is that what it's called? Just emitter. Type equals emitter. Like that. So this will only be targeting the type of entity emitter. In fact, let's do a case for this, because we're going to have other types of entity in the future. So just let me look up the switch statement syntax, because I don't use this one too often. It is switch expression switch and then current entity dot type, and then we go case emitter. And then break. So this should only print out for emitter entities. I think we need a colon here as well. Okay, definitely called emitter. Yep. All right. So we're going to. Oops. We're going to draw a little rectangle at its location, so we know where it is. G.fillRect. Current.x. Current.y. A width of 2, a height of 2. That'll do. So that should draw a little point somewhere up here on the screen. We should probably set that entity's fill style. We also need to set the X. We need to do based on the screen X. So it's actually where is it? Where's our tile drawing example? Here it is. Minus X and minus Y. And we should set the color as well. G.fill style equals, and we'll just make it a nice bright red so we can see it. So, what are people saying in this stream here? People talking politics and football. Nice to see you doing actual programming, not command blocks. Command blocks are programming. But I see what you mean. People saying it's too different from Java. People saying it's not too different from Java. And somebody saying they have to go. Okay, I'm all caught up. Let's see if that draws our little red square now. That'd be nice. Oh, fill rect. Rect. I just noticed that error was printing down there. Let's try that. Yeah, there's our little red point. I don't know if you guys can see it, but it's just here. That's our particle emitter, so that's going to be the end of the level. And if we move around, it does move the entity's position. Okay, so we've drawn our entity, which is actually purely temporary. In fact, maybe we should have that as a conditional. I'm going to leave it for now. Draw entity, because the emitters are going to be invisible anyway. So after we've drawn it, we want to cause it to trigger a function every time it every time a certain amount of time passes. So we've got our speed here of 500. So we want to go. We want to have a counter going up, like a game tick counter. So I'm going to go if ticks mod cur entity dot speed equals 0. So if the modulus of ticks results in 0, then we will call the function generate particle. Do we want to generate the particle in here, or do we want to generate it? Let me think. Yeah, well, we'll call it as a function so that we can do it in other places as well. Okay, so we're going to generate the particle, but the particle needs to know its coordinates. It needs to know what kind of particle it is. I wonder if we can just pass it the object, the current entity object, because that's got all that information anyway, like that. So we're going to generate a particle from this object, the current entity object, and then we will create this generate particle function, which I'm going to put down the bottom here. Source. Okay, and then here I'm just going to go console.log poof as it generates a particle. So we should see it every 500. Oh, we need to update. We need to count up the ticks as well. Var ticks equals 0, so that's the length of time the game has been running for. And we will do increase ticks plus plus. So we should see this print every now and again at a slower speed than the actual thing. Currently not printing anything at all. Which suggests that the function is not being called. Ticks mod current entity dot speed. Bfx says, why not just if ticks equal to current entity dot speed, because our speed is 500, and once our ticks, because our ticks are not going to reset to 0, it would only do it once. It would pass 500 and then it would go up and up and up, and it would never reach 500 again, so it would only generate the particle once, whereas we wanted to generate it every x. I think that's the right way around to do it. Let's log ticks as well. Console.log ticks to check this is actually incrementing. And let's just say let's get the calculator up and check this a second. So say our game ticks are we're currently doing ticks mod current entity dot speed, so we're going to go with 1000 mod 500 should return 0. Yes, it does. So I've got it the right way around. So why is it not running? Oh, it is printing it. It is printing poof. It's just really slow. Yeah, it's definitely counting up. So I think it's just poofing very irregularly, a lot less than I expected. I think because our ticks are going up 60 times a second. There are 60 ticks per second. And we are getting it to count up every 500 ticks. So I think it's much too slow. Yeah, you can see it just a little poof there. So if we change the speed of that to 60, that would run every second. So if we do something like 30, we should get 2 poofs per second. Maths. And refresh. We should see every half a second we'll get a little poof here. Yep, seems about right. Nice. Okay, cool. So we are going to generate an entity now. So what we're going to do is we've got our level array, which contains the entities list. So we're gonna add a new thing to the currently used level thing. So we're going to console.log level dot entities, like that. I'm going to slow it down a little bit as well so we can view this more carefully. So I'm going to go with 120. And we're going to, get rid of that. Let me think. We want to add a new entity to it. So we're going to go level dot entities dot push. I think push is the function I'm thinking of. JS push. I think that adds a new value to an array. Yes, it does. Great. So we should be able to push an object to our entities array. And this is going to be the particle, which we'll then process up here with the other particles. So we're going to push it. It's going to have an x of source.x. We will randomize that a little bit later. It'll have a y of source.y. It will have, what other information do we need? We need the texture. So we need the type is particle, and the particle is purple ball. Type equals, type is particle, particle equals source.particle. 15 Redstone says, I think you should put the JavaScript code in separate JS files, then it's clearer. Maybe in the future. The thing is, all of this runs in one big loop. I guess I could split it into functions and call the functions one after another inside my main loop. For now, I'm happy to leave it like this. Because I think it's technically a little bit less processor, a bit more efficient than having to call the functions every 60 times a second. Right. So our particle has an x and a y. As a type, it has a particle texture. It also needs an age, which is going to be 0, and we're going to use the age to tell when the entity should be deleted. So once the particle has finished particling and floating up into the sky or whatever we do with it, it will vanish. And we can use the age to change its properties and things like that. Good. Okay. So I'm going to save that, and we're just going to have a look at the entities object here and see whether we're getting entities like we want. There's our object. That's our emitter particle. This is our particle. The particle color is purple, type is purple, the age is 0, x and y have been passed correctly. All the information is there. If we look down here, you can now see that the object now contains far more entities. I wonder whether this is going to slow the game down. If we're going to notice a drop, we'll have to see how all of the different entities being processed will affect gameplay. I believe Spider Robot Man actually made an edit to my code which causes it to check itself and make sure that its frame rate is not dropping below 60, and it kind of forces it to reduce its FPS to keep the speed going correctly or something, which is kind of interesting. No Nines, hello, welcome to the stream. We're working on particles right now. So our particle entities are being generated, which is great. Now we just need to process them. So, case emitter. We've got our emitter working. So now we're going to case particle. Break. Great. So our particle entity is going to have to do a couple of things. It's going to have to draw the particle at its location, and we need to give it movement behavior and also destroy it if it's reached a certain age. So let's have a think here. Purple ball. What's the image called? The image is called particle 1. Let's actually call this particle 1 as well. And I actually deleted my image generation code, so I'm just going to look that up again. Okay, so we're going to do g.drawImage. I think I apply the particle to a variable. Yeah, particle 1 So particle 1 is the image. The x is current entity dot x, and the z is current entity dot y. I may have said z there. So that's the image texture, the x and the y. Minus x, of course, and minus y, so that it moves with the screen. We're going to add to its age at the end here. Current. Oh, hang on, we can't. I think we can edit it directly. Current dot age plus plus. I think that'll add to its age over time. We should check that. If we need to delete it if it's reached a certain age, and we want to make it move up as well. So we're going to go current dot x plus plus, sorry, dot y to make it move upwards. We'll add a bit more complex movement to it in the future, but I think that's going to be good. Yeah. Okay, let's see what happens. We should hopefully see the particles move up as soon as they spawn and draw the particle 1 image at their location. Oh, well, yeah, getting the wrong direction, but I keep doing that. I keep adding to the x to make it go down for some reason, which isn't correct. Now, so that's looking pretty good. So we can go if current entity dot age is equal to it's greater than 20, 60, which would make it last for a second. Let's go with like 120 for 2-second age particle. Then we will destroy the particle. The way we destroy the particle is we just remove the particle from the list of entities. Let me just move around here a second. Yeah, they are being drawn in the correct place as we move. That's good. So how do we remove pull? Is there a pull for? I always have to look this up every time I use it. JS remove from array. Array.splice index and number. Great. So what's the array name? Level dot entities dot splice I, which will be the current one, and a length of 1. So it should delete the entity once its age reaches 120. Beefx says just note particle 1 texture is forced. I'm not sure what you mean. Oh right, because yeah, you're right. I need to pull that, don't I? Thank you. Current dot particle, like that. Good spot. We have a lot of objects right now because they're not getting deleted. Right, let's see what happens. They should be rising up and they should delete themselves after 2 seconds. Nope, we're getting uncaught type errors. Failed to execute draw image. The provided value is not of type image. Current.particle. What have I done wrong? I think it's because I'm referencing a string, not a variable. Can I actually go like this and actually pass it the variable? Although the variable is declared down here, that could cause problems. Actually, it might end up just creating... We'll see what happens. I think we might get an error here. Yeah, particle 1 is not defined. We kind of need to move our level, our particle declarations up above everything else. Or I guess we could move our game declaration 2 down with all the other code. There we go, that should fix it. So what we should see is particles appearing, particles disappearing, and that's kind of looks very weird because of the age to speed. Let's up the particle speed a little bit and make it 60 is 1 times a second, 30 is twice a second. Let's go 25. Should see much more particles. Looks pretty good. Pretty nice. It's a particle emitter. Nice. So next up, I think we want to randomize its position based on the width. So we'll use math.random for that, I think. So actually, just this little sidetrack here, I'm going to remove this function is touching left wall. I'm going to change this to is touching wall because I changed them up and they're now identical. And then over here, I'm just going to place these like this. There we go. And okay, what was I doing? Our particles are down here. So removing it if its age is too great. We want to calculate some variance to their spawn, their starting x. So we are going to, let me see. I have to look at math.rand for JS. JS math.rand random math.random. Start x equals start x equals math dot floor, which makes sure it's a whole number. Actually, we don't even need to do that. We can have oh no, I think we do need whole numbers for our pixels probably. Is the stream still up? Yeah, it is still running. Okay, good. Math.floor, which will round it. Math.random times the min minus max plus min. The minimum is 0. Plus, oh, hang on, no, the minimum is 0 and the maximum is current dot width. Current dot width minus 0, and obviously adding minimum would just be adding 0, so we can skip that part. So here we can just put start x and see what happens. Nothing. Okay, now it's just not drawing them. Console.log start x. Math.random times current.w, which is 40. Apparently the delay is quite high at the moment on the stream, unfortunately. Current entity.x minus x. Console.log start x. It's not logging anything. I don't think I saved, that's why. Not a number. There's our problem. Math.floor. Math.random. That's weird. Do I need to pass int on this? Oh, on this. I'm also doing max minus min, and min is 0, so I really don't actually need that there at all. So I'm just doing random times the max width. Still not a number. Math.random. Okay, well I'm gonna print math.floor chooses the lowest whole integer, and math.random chooses the closest whole integer. So I guess it doesn't really matter which way around we do it much. Let's try logging current.w and see what we get there. Should just print 40 over and over again. Undefined. Okay, so that's our problem. Current.w. Our entity has a w of 40. W40. Current.w. It's weird, it's reading all the other values. Wait, current entity, yeah, no, that should work fine. I don't think it should be x minus start x, because all our other coordinates are done by x minus x and y things like that. So I'm pretty sure it's that way around. Why is current.w not a valid value? Generate particle source. We're not passing it its allowed spawn width. That's why. W is source.w. There we go. Fixed it. Let's refresh that. I think they might be being spawned a little off, and their position is being randomized every time rather than just the first time when they first spawn. Interesting as that is, I think we should probably change that. Where is this? Hang on. Oh yeah, we've been putting it in the wrong place, that's why. This... is a cur end.x, and then down here when we actually generate the particle, here we take that and we get rid of that and we set the x to start x. People are saying it looks like DNA. Kind of does, yeah. Okay, so they're spawning in the wrong place, but they are spawning at a random location. So that's looking good. Okay. Okay, so why is it spawning over there? Particle. Draw image. Current entity dot particle. Current entity dot x minus x. Current entity dot y minus y. They are moving with us, but they're in the wrong place. people are really lagging behind on the stream, but because they can see the live version of the game, they're kind of just commenting on what they see being changed. I could always, yeah, I might restart the stream. How long have I been going for? 43 minutes. Okay, I'm gonna restart the stream, and then hopefully we'll be kind of on the same page a bit more again.